NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math video on the distributive property of multiplication. Today we'll learn about an important property that allows us to multiply a number by an expression with multiple terms. The distributive property of multiplication tells us that when we multiply a number by a sum or difference, we can distribute the multiplication across each term and then combine the results. Let's look at the formal definition. For addition, the distributive property states that a times the sum of b plus c equals a times b plus a times c. Similarly, for subtraction, a times the difference of b minus c equals a times b minus a times c. Let's go through some examples to understand this property better. For our first example, let's multiply 5 by the expression 2x minus 3y minus 1. Using the distributive property, we multiply each term inside the parentheses by 5. First, 5 times 2x equals 10x. Next, 5 times negative 3y equals negative 15y. Finally, 5 times negative 1 equals negative 5. Combining these results, we get 10x minus 15y minus 5. Now, let's look at a slightly more complex example. Here we want to multiply 2/3 by the expression 6x squared minus 3x minus 9. Again, we'll use the distributive property to multiply each term inside the parentheses by 2/3. First, 2/3 times 6x squared equals 4x squared. Next, 2/3 times negative 3x equals negative 2x. Finally, 2/3 times negative 9 equals negative 6. Combining these results, our final answer is 4x squared minus 2x minus 6. Let's visualize why the distributive property works with a simple area model. Imagine we have a rectangle with width a and length b plus c. The total area of this rectangle can be calculated as a times the quantity b plus c. But we can also split this rectangle into two smaller rectangles, one with dimensions a by b and another with dimensions a by c. The area of the first smaller rectangle is a times b. The area of the second smaller rectangle is a times c. Since the total area doesn't change when we split the rectangle, we can say that a times the quantity b plus c equals a times b plus a times c. And that's the distributive property. The distributive property has many practical applications. For example, imagine you're shopping and want to calculate the total cost of 3 items that cost $5 each. You could calculate this as 3 times $5, which equals $15. But what if the items have different prices? Let's say you're buying items that cost $5, $8, and $12. Using the distributive property, you can calculate the total as 1 times the sum of 5 plus 8 plus 12, which equals $25. Now imagine there's a 20% discount on all items. Using the distributive property, you can calculate the discount as 0.2 times the quantity 5 plus 8 plus 12, which equals $5. Therefore, the final price would be 25 minus 5, which equals $20. To summarize what we've learned today, the distributive property allows us to multiply a number by each term in an expression and then combine the results. Mathematically, a times the quantity b plus c equals a times b plus a times c. Similarly, a times the quantity b minus c equals a times b minus a times c. To apply the distributive property, step 1, identify the factor outside the parentheses. Step 2, multiply this factor by each term inside the parentheses. Step 3, combine like terms to get the final result. Now, try these practice problems on your own. 1. For 3x plus 2y, 2. Dash 2, x minus 3y plus 5, 3. 1/2, 8x superscript 2 plus 6x. 10. Pause the video and try to solve these problems. When you're ready, continue to check your answers. Let's check the answers to our practice problems. For the first problem, 4 times 3x plus 2y, we get 12x plus 8y. For the second problem, negative 2 times x minus 3y plus 5, we get negative 2x plus 6y minus 10. For the third problem, 1/2 times 8x squared plus 6x minus 10, we get 4x squared plus 3x minus 5. I hope this video helped you understand the distributive property of multiplication. Remember to practice this concept as it's a fundamental skill in algebra and appears frequently in more advanced math topics. Today we'll learn how to find the additive inverse of a polynomial expression and understand the meaning behind this mathematical operation. Let's start with a basic definition. The additive inverse of a polynomial is what we get when we multiply the polynomial by -1. If we have a polynomial, a, then its additive inverse is negative a, which we can write as -1 times a. We denote the additive inverse of a as negative a. Now, let's look at a specific example to understand how this works in practice. Let's find the additive inverse of this polynomial. Step 1. We'll apply the definition of additive inverse. The additive inverse of a is negative, which equals -1 times a. So we have negative a equals -1 times open parenthesis 2x squared minus 3x plus 5 close parenthesis. Quick challenge. Can you predict what happens when we distribute the -1 to each term in the polynomial? Take a moment to write down your answer before we continue. Step 2. Now let's distribute the -1 across all terms in the polynomial. When we multiply each term by -1, we change the sign of each term. So 2x squared becomes -2x squared. -3x becomes +3x. And +5 becomes -5. So our result is negative a equals -2x squared plus 3x minus 5. Let's summarize what we've learned. The additive inverse of a equals -2x squared plus 3x minus 5 is what we've learned. The additive inverse of a equals -2x squared plus 3x minus. The final answer is negative a equals -2x squared plus 3x minus 5. We can verify this is correct because a plus -a should equal 0. Let's quickly check. 2x squared minus 3x plus 5 plus -2x squared plus 3x minus 5 equals 0. So our answer is correct. To summarize, the additive inverse of a polynomial is found by multiplying each term by -1, which changes the sign of each term. This concept is important in algebra and has many practical applications, such as solving equations and manipulating expressions. Thank you for watching this MathGPT video on additive inverse of polynomials. Today we're going to explore some important algebraic identities and verify them using numerical examples. These identities are powerful tools that can help simplify complex algebraic expressions. Let's start with our first identity. The first identity states that negative of a difference equals the negative of the first term plus the second term. Written algebraically, we have negative of a minus b equals negative a plus b. This may look a bit abstract, so let's verify it with a numerical example. Let's try a equals 3. Now let's substitute this value into both sides of our identity and see if they match. First, we calculate the left side, negative of a minus 4. Substituting at equals 3, we get negative of 3 minus 4. This equals negative of -1, which equals +1. Now, for the right side, negative a plus 4. Substituting at equals 3, we get -3 plus 4. This equals 1. Since both sides equal 1, we've verified that the identity negative of a minus 4 equals negative a plus 4 is true for a equals 3. Let's understand why this identity works. The distributive property tells us that when we have a negative sign outside parentheses, it distributes to each term inside, changing the sign of each term. So negative of a minus b becomes negative a plus b because the negative sign changes the signs of both terms inside the parentheses. Now, let's move on to our second identity. This identity is a generalization of the first one. It states that negative of a minus b equals negative a plus b. Let's verify this with another numerical example. Let's take a equals -1 and b equals 2. First, let's calculate the left side, negative of a minus b. Substituting our values, we get negative of -1 minus 2. This simplifies to negative of -3, which equals +3. Now for the right side, negative a plus b. Substituting our values, we get negative of -1 plus 2. This simplifies to +1 plus 2, which equals 3. Since both sides equal 3, we've verified that the identity negative of a minus b equals negative a plus b is true for our chosen values. Welcome to our lesson on the distributive property in algebra. Today we're going to explore a specific algebraic identity and verify it with numerical examples. The distributive property is a fundamental concept in algebra that allows us to simplify expressions. Let's look at a specific algebraic identity x minus the quantity y plus z equals x minus y minus c. This identity applies the distributive property of subtraction over addition within parentheses. Let's understand what this means and verify it with examples. Let's work through our first example. We'll verify the identity when x equals 0 and z equals 1. Let's substitute the values into our formula and evaluate both sides. First, let's calculate the left side of the equation, x minus the quantity 2 plus c. Substituting x equals 0 and z equals 1, we get 0 minus the quantity 2 plus 1. This equals 0 minus 3, which is negative 3. Now, let's calculate the right side of the equation, the quantity x minus 2 minus z. Substituting our values, we get the quantity 0 minus 2 minus 1. This equals negative 2 minus 1, which is negative 3. Since both sides equal negative 3, we've verified that the identity holds true for these values. Let's verify our formula with another example. This time, we'll use x equals 1, y equals 2, and z equals 0. Let's calculate the left side first, x minus the quantity y plus c. Substituting our values, we get 1 minus the quantity 2 plus 0. This equals 1 minus 2, which is negative 1. Now, let's calculate the right side, the quantity x minus y minus z. Substituting our values, we get the quantity 1 minus 2 minus 0. This equals negative 1 minus 0, which is negative 1. Again, both sides minus 2 minus 0. This equals negative 1 minus 0, which is negative 1. Again, both sides equal negative 1, confirming that our identity is true. Let's understand why this identity works. When we have an expression like x minus the quantity y plus c, we're subtracting the entire sum y plus c from x. By the distributive property, this is equivalent to subtracting each term individually. So, x minus the quantity y plus z equals x minus y minus c. We can also think of this as x minus y, and then subtracting z from that result, which gives us the quantity x minus y minus c. Let's visualize this property with a geometric interpretation. Imagine a rectangle with width x. We want to subtract a region with width y plus c. We can subtract this region all at once, which represents x minus the quantity y plus c. Alternatively, we can subtract a region of x minus the quantity y plus c. Alternatively, we can subtract a region of width y first, and then subtract another region of width c, which represents the quantity x minus y minus c. The result is the same either way, which visually confirms our algebraic identity. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.